Hey guys, welcome back to my algorithms video. It's been a while, I know. It's been like 3-4 days. Today is I think day 56. Thought before getting too late, I might as well do some algorithms videos once in a while to match up the speed of the upload of the Dutch video. Anyways, we're gonna continue with uh the sliding windows, although the problem that I solved today had a tag sliding window on it, because on Leetcode you can search for specific problems that involve these type of questions. This didn't seem like it would require it, although I tried to solve it using a sliding window with some help as well. Let me just share my screen so that you can also see what kind of question it is. So the question is, defuse the bomb 1652. You have a bomb to defuse. Your time is running out. You're for a circular array code of length n and a key k. So if k is more than 0, we replace the ith number with the sum of the next k numbers. If k is less than 0, replace the ith number with sum of the previous k numbers. If k is equal to 0, we replace the ith number with 0. So what happens is that to find the 0th element of the output, we add the next 3 numbers. So that will be in this case 714. So that will be 12. So we put 0th element of the output as 12. Let's say for the second element, 012, index 2. So from here, the only element is this array is circular, so that means after 4 it goes back to 5. So 4 plus 5 plus 7, because k is 3, so we add the next 3 numbers. So that will be 4 plus 5 plus 7 is 16, which becomes our second element of the output. Same goes for this case too. This case is kind of exceptional because k is 0. That means we don't add any of the next numbers. So that means the result array will be consisting of 0. This is where I got the idea of filling the input, the array that we would keep as a variable to collect all the output as 0, so that if anything else, nothing happens, then we keep it as 0. So that will be the edge case. Same goes for example 3. I think there's no more example needed. If you see the third element, which is 3, we add -2, so that will be going backwards 2 elements, so 9 and 4, so that becomes 13. So yeah, you have to take care of plus, minus, and 0 of the k instance. So let's how are we gonna try to solve this? So if we put it let me just no 1 second. So if k is more than 0, that means we sum the next k elements for each of the index in the array. Considering the circular nature, we can maintain a sliding window. So how are we going to use this? By subtracting the element that leaves the window and adding new elements that enter the window. So the window keeps the same. The window is a length of k, and just moves, and when it reaches the end of the array, um, the last element leaves the window, and then we add the new element from the start of the array. If k is less than 0, that means we sum the previous k elements, the absolute k elements, considering the circular indexing. If k is equal to 0, we simply return an array of zeros, because problem specifies for k equals 0, we add 0 elements, 0 index elements. So that will be adding nothing. So how are we gonna code this? So let's put n as the length of the code that we have. And if k equals 0, let's start with the most simple one. 0, that means return the array filled with zeros. That would be n. We need a variable that I told you guys about that would keep the result of the array. So we would specify that as a variable. So our result is array filled with n zeros. And if k is more than 0, then the window sum of the window will be sum of code is the input list, so initial window sum. So that will be next k elements. So code, we start from 1 and to the k plus 1, right? Because we have to sum the next k elements. And for I in range, and then the result, the index I in result, so the ith element in a result will be replaced by the window sum of the window, and window sum will be then slided. So it will be minus the, we're not using the pointer here, just the index code I plus 1 modulo n, and window sum plus the code I plus k plus 1 modulo n. So here we slide the windows, so we subtract the element that's moving out, and here we're adding the element that's coming in. So that will be done by finding the remainder of I plus k plus 1. New element entering the window. And since we covered k is more than 0, and if k is less than 0, then that will mean let k be absolute. Window sum will be still sum of code. This time it will be from previous k elements, so that will be minus k. And for I in range n, we kind of do the same structure. So result I will be window sum. We specify the sliding window range, and window sum minus the code I minus k. We subtract the elements that's leaving the window, and that we found it by calculating the remainder. And we do the same for the ones that are entering the window. So that would be code I. Yeah, and we return the results. And let's see if this works so that I can move on. Nope. Sum of code 1k plus 1. I think that was capital K, so that's, yeah, should be K. Oh yeah, guys, it works. But let's see what the time complexity is. Oh, it's actually quite fast. It is time complexity of ON, because we're still using the sliding windows solution. But yeah, that was it, guys. For the next few days, we're just gonna keep on digging this sliding window and try to solve some more questions. Thank you guys all for watching. If you guys have any questions, leave it down below, and I'll see you guys in the next video. And if you guys could subscribe, I would also appreciate that.